Hello everyone. It's our pleasure to share our solutions in the VizWiz Answer Grounding Challenge this year. I would like to give a video recorded presentation of our work in VizWiz Answer Grounding. From left to right, our team members are Ringgang Li, Yaqian Zhao, Hongwei Kan, Zhenhua Guo, Baoyu Fan, Runs Zhang and Xiaochuan Li, respectively. I will introduce our work from the following aspects. VizWiz Answer Grounding dataset comes from the VizWiz VQA. VizWiz VQA stands for a dataset including photos taken by blind persons with 1 recorded spoken question and 10 crowdsourced. The answer grounding task aims at grounding answers to visual questions asked by people with visual impairments. As shown in the image above, the question is asking the relevant brand of the product and the ground truth is just the brand area. There exists a similar task named referring image segmentation. For the common referring image segmentation, the text caption may just be the silver bag and not care about the detailed information on the bag. The text caption in the referring image segmentation has direct link to the ground truth mask area while there exists no direct link for the VizWiz answer grounding. We focused on the answer importance because it may be the anchors connecting the question and the image like the object tags in the Oscar model. We then designed the models combining the VQA answers as anchors. We split the process into 2 stages. Firstly, we trained the VizWiz VQA dataset and obtained the high-quality answer for the given question. Then, we combined the answers obtained in the first phase and modified the vision grounding model to adapt the answer grounding task. Firstly, we should train the high-quality VQA model to get a relatively accurate answer. We employed the blip model, which put forward the multimodal mixture of encoder-decoder. We trained the blip model according to the blip paper and obtained the VIT large model. When fine-tuned in the downstream datasets, we first fine-tune our model in the VQA, GQA, Visual Genome, Text VQA as well as the VizWiz VQA dataset. Finally, we fine-tuned the VizWiz VQA dataset for the answer prediction. The training image size is larger compared to the original size in the paper and the other HIPAA parameters are the same as the blip paper. The final multi-model fusion result can obtain 66.34 accuracy in the test dev phase. In the second stage, we trained our answer grounding model. We modified the MDETR model by adding the answer encoder module and the mask head module like mask RCNN. We took similar strategy like in VQA model. We first pre-trained the original MDETR model using the combination of Flickr 30K, Ms. Coco, Visual Genome. We employed the efficient net series network as our vision encoder. During the fine-tuning phase, we firstly fine-tuned the model on a larger dataset phrase cut and ref cocked and we firstly trained the detection model and then trained the mask head module with the other parameters frozen. The experiments demonstrated that the multi-stage fine-tuning strategy and fine-tuning on larger dataset are effective. Through the challenge, we summed up the relevant tricks for the VizWiz answer grounding. Firstly, the answer anchors play an important role in the answer grounding compared to the common referring image segmentation. Secondly, when fine-tuning on a dataset with limited size, fine-tuning the model on a larger dataset may sometimes reduce the gap between the pre-training phase and the final fine-tuning phase. Thirdly, when faced with the segmentation task, firstly training a high-quality detection model is necessary. Finally, the deeper vision model is not efficient as in the other strategies. Maybe I did not adjust the HIPAA parameters to the best state. Thanks for watching the video.